All right, and we're probably not going to do every single problem. We just do not have time. So really try to focus in. If you have specific questions, Laney, if you have specific questions, make sure you're asking. So take out your notes and let's go. All right, here we go. Example number 2, product. So here we are multiplying two imaginary numbers, okay? So first of all, we are going to rewrite each one, which is going to be as a positive number times -1 times, in this case, the square root of positive 15 times -1, because we can break those apart, all right? Then, using the cake method, we can take that 10, and 10 is an even number, okay? We can divide it by 2 and get 5. We can divide 5 by 5. Remember, we only divide by prime numbers, and we can rewrite that square root of 10 as 2 times 5. And I'm going to break apart that negative square root of -1 to be by itself, okay? Times, I can do the same for the square root of 15. All right, the square root of 15. I can divide 15. It's not even, so I can't divide by 2, but it is divisible by 3. And I get 5. 5 is divisible by 5, and I get 1. And remember, when you reach 1, that's supposed to be your little candle. That's how you know you are done. So I'm going to rewrite the square root of 15 as these two things, which is 3 times 5. Times, and I'm going to put that square root of -1 by itself. All right? So now I'm going to put all of the numbers, the regular numbers, together under one big square root. Okay, so that's going to be 2 times 3 times 5 times 5. I know the square root of -1, they said, is now an I. Okay, come on in. Shut the door, please. The door. Forte. What? How you say please? Please. Luga. I gotta learn some Spanish. So that's going to be an I for the first one times an I over here. Now, from the cake method, anytime you have two of them together, that's like 5 squared. Stay off the phone, put the phone away. So 1 gets kicked out. So 5 gets kicked out in front. 2 and 3 do not have a second number with it. So I'm just going to multiply those and leave it under the radical. And if you remember, I is the square root of -1. So I times I is going to be times -1. Now, putting that -1 multiplied by those gives me a final answer of -5 times the square root of 6. So you need to remember from yesterday, the square root of -1 is our imaginary number. So we change that to an I. And if you happen to have 2 i's multiplied, then that gives you -1. So this is just a reminder from yesterday. Questions on that? All right, let's take a look down here at the check. So each one is a square root of a negative number, all right? Let's rewrite it as the square root of the positive 16 times -1. And the second one is the square root of positive 25 times -1. Now, I'm going to do one way in case you know that 16 is a perfect square. Okay? Actually, no. I'm going to do this one as if it's a perfect square because it doesn't have any other values. This one, we're going to use the cake method. You can always use the cake method. Always. You can use it. Always can use. But you can only use the perfect square method if you have a perfect square. All right? So 16, that is a perfect square, but let's say you didn't know that. You can use the cake method. So bring it down here. Start with that number 16. 16 is even, so I can divide it by 2, my smallest prime number, and get 8. 8 is even, so I'll divide that by 2 and get 4. Marvin, you need to take out your notes. This is notes, okay? That's even, divide by 2, get 2, and you keep going until you reach 1. So all of these values are the prime factorization for that 16. So I'm going to rewrite it as 2 times 2 times 2 times 2. The square root of -1, I'm going to put separate. Okay. Over here, let's say you know that 25 is a perfect square. All right. That would mean I am going to have some number squared, which gives me 25. Well, what number times itself gives you 25? 5. Okay? And when you take the square root of something that is squared, it's like saying, this is kind of like saying it's 5 times 5, which would be a double, which you would cancel out, okay, or take one out. So that is the same, and then my last one, I'm going to say times the square root of -1. So in my next line, I see I have 2 pairs. So for every pair of numbers you have, 1 from that pair, Sandra, comes on the outside, okay? So I got 2 on the outside from this one. I take 1, 2 on the outside from that one. The square root of -1, I know, is an I. Over here, when you take the square root of something squared, these cancel out. And so that gives you 5 on the outside. Delaney, you need to be writing this down. Okay. And this last one, this is going to be another I. So multiplying this all together, I get 2 times 2, which is 4. 4 times 5 is 20. And I know that I times I, or that I squared, is a -1. So 20 times -1 gives me a final answer of -20. Questions on that? I always think this is difficult. Is it seeming a little difficult now? It's a lot, isn't it? Okay. Let's do one more of this type. Let me figure out which one. Okay. Do I have time for one more? I will do one more, and then I think the next two things we have to do are much easier. Okay? Yes. Yes. Which line? Let's say if this is line 1, line 2, line 3. The second line, okay. After this x, this 2 right here. When you take the square root, so before, when you take the square root, we usually don't put the 2 up there. Sometimes it's a cube root. Do you remember that maybe in your past? Maybe it's a fourth root. But when it is a square root, it's kind of like one understood. We don't have to write it there, but if I have 5 squared, which is the same as 5 times 5, when you take the square root, it's like these could cancel out. So no, this usually is not written in, but I'm just showing you if I had a fourth root and I had 2 to the 4th power, the fourth root of 2 to the 4th power, these would cancel out and your answer would be 2. If I have the square root, which usually it's not written there, and it's just written like that, and if I say 6 squared, this imaginary 2 would cancel out with this, and my answer is just 6. So I wrote it there so you can see it can just cancel out, and whatever you have left goes on the outside. That is an excellent question. Excellent question. Okay, let's do this last one very quickly. So first of all, when you start with the square root of a negative number, again, change it to the positive value. So this becomes positive 12 times the square root of negative 1. Times, let's change that 5 to a positive 5 times the square root of negative 1. All right, 12 is not a perfect square, so we think cake method because we need to break this down. 12 is even. Divide it by 2, you get 6. Divide it by 2, you get 3. Divide it by 3, 3 is still a prime number, and I get 1. So I can rewrite the square root of 12 as 2 times 2 times 3. This square root of negative 1, I know it's going to be an I. So I just kind of skipped putting it separately. And then the square root of 5, 5 is a prime number. So that's not going to break down into anything smaller. And this right here, that square root of negative 1, I know that's going to be an I. So I'm going to group all my numbers together and say the square root of 2 times 2 times 3 times 5, because they're all under the radical, so we can do that. And then I have this I times I, which is I squared. Here I have 2 2's. I'm going to kick 1 out, so 2 comes on the outside. These do not share a second partner or number, whatever you want to call it. So that stays under the radical, and I can multiply those together. 3 times 5 is 15 times I squared, we said, is negative 1. So taking this times negative 1, final answer is negative 2 times the square root of 15. So the more you do these, hopefully the more you will get used to them and how they need to work. All right, let's go to the top of 14. Now, this does not say to solve by factoring. It does not say that. You need to look at the directions if there are any. This, we are actually going to solve by way of square roots. Solve by way of square roots. Kind of like algebraically. So what I want to do, I have x squared plus 81. I want to get that 81 over to the other side. Again, if we were solving by factoring, we would let it go and set it equal to 0. But I know this is a perfect square. So let's subtract 81. Subtract 81 on the other side. 81's cancel out. I get x squared is equal to negative 81. Now it's time to break out the square roots. I take the square root, I take the square root. And here the square root of anything squared is just going to be x equals, I am going to rewrite this as 81 times negative 1, right? So x is equal to, this is a perfect square. It is some number times itself. What is that number? Do you know? What number times itself gives you 81? 9, yes. So that is 9 squared times I. Now, here's the slightly weird thing. Usually when we take the square root, we always want the positive value. Okay, that is called the, what is that called? I can't remember what it's called, but we usually want the positive value. But we also know we can take the negative value of it too. So my final answer here is x equals the square root of 9 squared is 9, but it could be a positive 9, and it also could be a negative 9, because negative 9 times negative 9 also gives you that 81. Bless you. And the last thing here, I only have one I, is to multiply that by I. So x equals plus or minus 9i, which you could write out as x equals 9i and x equals negative 9i. But usually this is how we write it. Okay, that was a little confusing, right? Yes, I get it. Let's now do the same thing with letter B. We are solving by way of square roots, not by factoring. If it was by factoring, I would leave it as set equal to 0. So I want to move this to the other side. I am going to subtract 27 from both sides. 27 cancels out. 3x squared is equal to negative 27. I'm trying to solve for x. Divide by 3, divide by 3. X squared equals negative 9. Bring out the square roots. Square root. So the square root of x squared is x equals, anytime you have a square root of a negative number, make it the positive value times negative 1. Right here, 9 is a perfect square. That is 3 squared times the square root of that negative 1. And I am writing out every step just so you see, okay? Up here, if you take the square root of something squared, x is going to be equal to the positive value of 3 and the negative value of 3. I can't do that anymore. And this square root right here is going to be I. So x equals plus or minus 3i. You are going to need to refer back to your notes when you're working on your homework, okay? Especially since I'm not going to be here probably the next 2 days. All right, let us move on. This should be, I think, not too bad. These are called complex numbers, and they are adding and subtracting numbers when you have a real term with the imaginary terms, okay? I want you to think of 3i like a variable term, okay? It's just like saying 3x. So you put your x's together. In this case, you would put your i's together, and you're going to put your real numbers together, all right? So I'm going to go through this very quickly. I have 6 plus 4i plus 9 plus 3i. You cannot combine them, even though they are in a set of parentheses. Montre, let's watch up here, please. So 6 plus 9, I'm going to put those together because those are like terms. And then I have 4i and minus 3i, okay, plus 4i minus 3i. So 6 plus 9 is 15. And I look at 4i minus 3i is 1i. And you always put the real number first, the whole number by itself. So the final answer would be 15 plus 1i. Man, that's your final answer. The place where it becomes a little bit trickier is when you have the minus sign in between, because you need to distribute that negative sign. Okay? So let's look at B. It's kind of like we said we never subtracted polynomials. Right here, we don't subtract these. We change it to, we need to change this to adding the opposite. And I'm going to write those opposites right above. So this is going to be a negative 2, and this is going to be a minus 3i. So now we are looking at 8 and negative 2. So 8 minus 2. And you always need to check the signs in front. Then we have negative 5i and minus 3i. Put that together. 8 minus 2 is 6. Negative 8i minus 3i is minus 8i. You cannot combine those terms. It's like a whole number and a variable term. So 6 minus 8i is your final answer. See, now this isn't so bad, right? Yeah, I told you. I try not to lie to you, even though I'm a math teacher and it's like, oh, this is easy. It's like, no, this is not. Let's do C. Right here, we have a negative sign in front of the parentheses. We need to change that to adding, make the opposite of everything that follows. So this is a negative 3 and a minus 2i. And then put your numbers together. You got 4 minus 3. And with the i's, we have negative 6i minus 2i. 4 minus 3 is 1. Negative 6i minus 2i, or at negative 6, you take away 2 more, is minus 8i, and that is your final answer. Questions on that? Cha-ching! Why couldn't this all be like this? I know. Let's go to the last one. Actually, you try this. You try this one. This one has no subtraction. So it's just going to say simplify, simplify. Put your like terms together. Go ahead. Try it at your seats. Try it at your seats. Montre, Demarian. Montre. Oh, good. Montre. Look up. Montre. Do you hear me at all? Okay, well, take a breather and come up. Did you get any of these? All right, so if you put your like terms together, put the 8 and the 6 together, 8 plus 6. You put this, how many I's is that? 1. That is a 1 I, which you don't have to write the I, but you can. 1 I plus 4 I. So I am betting most of you got 14 plus 5 I. Raise your hand if you got that right. Rock stars! Nice. Any questions about simplifying complex numbers when you have real numbers with imaginary numbers? All right. I know it'd be great to stop, but since I'm not going to be here the next 2 days, we are going to move on. So let's go to the top of page 15, and we have actually worked with this before. Remember when I was saying b squared minus 4ac? You're going to see it later, and everybody kept missing it. And we were trying to get the same answer every time. Well, guess what? It is here. Solving quadratic equations using the quadratic formula. All right. Not all quadratic equations can be factored. We know that. We can use the quadratic formula. This whole thing right here is the quadratic formula, but that's not what we're doing today. In the quadratic formula, the expression under the radical sign is b squared minus 4ac. b squared minus 4ac. This was the one that we were like, substitute the numbers in and try to get a value. This is called the discriminant. So that value right there is the discriminant. You can use the discriminant to determine the number of real solutions. Okay? So, looking below, if b squared minus 4ac is less than 0, if a number is less than 0, then it is what? Negative, right? So if you have a negative discriminant, I'm going to put DISCR, then you have no real solutions. No real solutions. Okay? If it's less than 0, if it is negative, all right? Sometimes your discriminant is going to equal 0. So here, the discriminant is equal to 0. Exactly. Okay? When you have that, this is where you have the bounce, the double root, and you are going to have one real solution. And most of the time, if your discriminant is greater than 0, so if you have a positive number for your discriminant, it's showing like here, you are going to have 2 real solutions. The key in all of this is to simplify the discriminant correctly. And that's what we had problems doing before. All right. So everybody got this written down. You guys are doing great. It's a lot of information. I still think the toughest is working with negative square roots. I think you would agree. Let's take a look at example 4 at the bottom. It says, state the value of the discriminant of 4x squared minus 3x equals negative 1. Then determine the number of real solutions. All right. First of all, you have to set it equal to 0. It has to be written in standard form. Set equal to 0. Okay? Set equal to 0. Has to be in standard form, which is a squared plus b squared, bx plus c equals 0. So that means I would need to add 1 to both sides. Negative 1 plus 1 is 0. And adding that 1 is not going to do anything to your first two terms. 4x squared minus 3x plus 1. There it is. That is standard form. Isn't that beautiful? All right. Now, let's flip to the next page. I need to remember, 4x squared, negative 3, 1. I'm going to rewrite it up here. 4x squared minus 3x plus 1. It was plus 1, right? Hate it when I do that. Yes, plus 1. So now that that is in standard or general form, we need to write down the a value, the b value, and the c value. What is my a value? Anyone? Not the x, always just the number, but good. Yes, the 4. That is your a. What's my b amount? Negative 3. And c is 1. And they always go in order, A, B, C. But don't forget the signs in front. All right. Now, we need to substitute the a of 4 into this expression, the b of negative 3, and the c value. So b is negative 3. And that gets squared. Remember, anytime you have a negative value, please put it in parentheses for the love of goodness. All right? Minus 4. That 4 is part of the formula. So is this minus. So is this 2. Times a. So I'm going to put times a. I'm going to put that in parentheses. And times c, which is 1. All right, here is how I have told you to do it in the past. You take it as this number first minus this number, because you have to do all that multiplication. So negative 3 squared is how much? Come on. What? Nope, it's not negative 6. A negative times a negative is a positive, and 3 times 3 is 9. Guys, this answer, whether it is a negative or whether it is a positive, is always going to be a positive number. Anything squared is always positive. So it's 9 minus, okay? Now, let's work with the second box. 4 times 4 is 16. 16 times 1 is still 16. So it is now 9 minus 16. That is a negative 7. That is your discriminant right there. Okay? Because the discriminant is negative 7, it has no real solutions. That means it's a parabola and it is not going to cross the x-axis. 0 solutions. I don't like saying 0. I'd rather say no real solutions. All right, so let's do the same thing for the next problem. State the value of the discriminant of this equation. Well, first of all, I can't work with that as it is. That is not in general or standard form. Okay, so I would need to add 9 because it has to be set equal to 0. Add 9 over here. 9's cancel out. I get x squared, 8x squared, sorry, minus 15x. Nothing changes with the first two. And then plus 9 equals 0. All right, I'm going to figure out what my A, my B, and C is, okay? A is equal to how much? Edgar, what is my A value? Good. A is equal to 8. B is equal to negative 15. Check your sign in front. Negative 15. And C is equal to 9. The discriminant is B squared minus 4AC. B is negative 15 squared. Remember, anytime you have a negative value, put it in parentheses. Minus 4 times my A value of 8 times my C value of 9. We got some big numbers here. Quantity, negative 15 squared. Edgar, I don't think that's a calculator. What is 15 squared? Negative 15 squared. 225. Is that positive or negative? Positive. Anything squared is always positive. Marvin, stay with me. Minus, okay? We did this. You get that answer. Now we're going to get this whole answer. What is, and don't put the minus with the 4. It's not a negative 4. It's minus box. Minus the whole box. 4 times 8 is 32. 32 times 9, I don't know. 288. 225 minus 288 is going to be, check my math, negative 63. Is that right? I think so. So that discriminant is negative 63. Because it is negative, it is going to have no real solutions. If my answer for the discriminant is 0, then that is one real solution. And if my answer was a positive number, going back to here, 2 real solutions. All right. So tomorrow, check on Canvas. I'm probably going to have you do the skills check first. All right. The skills check is not going to have the discriminant stuff on it. So complex numbers, adding, subtracting, negative square roots, all that stuff is game. So skills check tomorrow. And homework number 3 technically could be turned in tomorrow. Okay? I expect you guys to be on your best behavior. I expect you to do some work. Okay? Next Thursday is the SAT, so we will not have class next Thursday. And even though I don't love it, I think I'm going to have to do the test next Friday. So we will review On Wednesday, I don't know if we'll get 2 days of review or just one. And then test is probably on Friday with a day in between where you will not have seen me. All right? Just do your best, do your work, keep your nose clean. You know what I mean? No burgers. Okay. Let's see what we have for announcements.